I think trying to operationalize that and tie that back to, oh, this, here's an eval that we can run that will capture, is there a causal inference here, for example? And those sorts of things, I think it's just you define the set of things that you measure, assess whether those measurements are reliable. I mean, that's a major problem, is that you can have unreliable instruments.
Yeah.
Improve the system under those measurements and then sit with it in either a production environment or in a playground environment where you can just look at a lot of examples and then improve your measurements and then push it to prod and then improve your measurements, watch it, push. And so I think it's that kind of it's like tightening a ratchet, where it just gets tighter and tighter and tighter. And it just has less room to do the thing that you don't want it to do.
This is Deployed, the AI Product Podcast, and I'm your host, Ian Cairns, co-founder and CEO of FreePlay. Hey, we're back today. Excited for you to hear from Mike Conover, who is co-founder and CEO of Brightwave, also here with us in Boulder, Colorado. Brightwave is an AI startup that focuses on helping financial researchers make sense of tons of data using generative AI. His background is as a machine learning engineer. He was at LinkedIn, Workday, most recently at Databricks. He's got a lot of experience in this space. And on this episode, he's going to spend time talking about what works and what doesn't with LLMs, some of the differences working with traditional machine learning models, and what they've brought over into working on LLMs with his team at Brightwave, what they've done differently. He's also going to share some insights about how they work to build great evals, iterate on their systems, improve quality, how they involve different people on their team, including finance experts who maybe are not traditionally involved in product and engineering. So lots of good stuff in here that I think is relevant to anybody building with LLMs. Excited for you to hear from him. And with that, we'll jump in. Hey, everybody. Thanks for joining. I am joined here today with our friend Mike Conover, who's CEO and co-founder at Brightwave. Mike, I'm going to let you introduce yourself. Tell us a bit about who you are and what you're working on, and we can go from there.
Yeah, it's a pleasure to be here, Ian. Thanks for having us. As you know, I'm Mike Conover. Have been building AI/ML systems for the better part of 15 years. Most recently at Databricks, where I created a language model called DALL-E that was the first to demonstrate that open source models could exhibit the kinds of instruction following behaviors we've come to expect from ChatGPT. It seems obvious
that was
now.
Awesome.
Yeah, but the people that knew that in April of last year weren't talking about that fact. But yeah, have a long history of building machine learning technologies. I was at LinkedIn for many years and had worked on their homepage newsfeed relevance algorithms and knowledge graph construction startup called SkipFlag that was acquired into Workday, which is part of what brought me here to Boulder, Colorado. And Brightwave, we are building an autonomous AI research assistant that can synthesize and distill down insights about the global economy into tight, actionable financial research on any subject.
Yeah. Tell us more. When you say what you just said, who are your customers? What are they doing with the software today? Just for people that might not be close and know what Brightwave is.
Yeah.
Give us a little bit more color.
So if you think about the job of an active asset manager, it's to understand something about the world that nobody else has seen in order to identify a mispriced asset. And our assessment is that is not a task that is well suited to human intellect or attention span. And it's not clear that language models give you superhuman reasoning capabilities from human level demonstrations of skill at pre-training time or fine tuning. Yeah. It's definitely not clear. They may eventually, but it doesn't seem to be the case today. However, from a working memory standpoint, these technologies eclipse what is possible for a human to understand and perceive simultaneously. And the ability of these systems to connect the dots across many different documents and identify fact patterns that would escape human notice and reason over bodies of content that are extraordinarily large is an important fact about the technical state of the art. So we're building a system that augments human cognitive capacity and allows a human financial analyst to direct the attention of an AI system that is able to assess what kind of information would be relevant to developing and hardening a thesis. For example, how is NVIDIA's position in the GPU market impacted by rare earth metal shortages?
Yeah.
It will consider the topic from multiple different perspectives in order to comprehensively consider the subject at hand and Brightwave organizes its research into easy to digest, information dense research reports that have sentence level attribution to the underlying primary sources, that are very high quality and living documents. With Brightwave, you can deepen and refine your understanding. We've developed a lot of new user interaction paradigms that we think define natural ways to interact with language models that we're not seeing in other product surfaces. And our customers are extremely pleased with the capabilities that we've brought into the market, and we're just getting started.
Yeah, that's awesome. There's a bunch of stuff you just talked about that you mentioned, some of the UX things that you're doing, some of the approaches to how you're interacting with LLMs. I think for people that are likely watching this, there's a lot of folks that are trying to figure out, how do we actually make this stuff work well in production?
Yep.
You've been on a journey to get where you are today. What can you tell us? What do you feel like you have, maybe if you want to start with the negatives, what didn't work? I'm sure people are curious about. If you want to start with the positives, let's cover both.
Yeah.
Just be cool to hear you riff a little bit more about process, tactics, what have you done that's made it work well, and how did you get here?
So in terms of things that surprised me, the first thing that comes to mind is a year and a half, 2 years ago, really believed that large context windows would be more useful than they have turned out to be.
Yep.
If you think about the structure of the self-attention matrix and how it looks at the relationships between words in a sentence, there are mathematical reasons to think that it would identify long-range correlations in very large bodies of text, and that it would be able to stitch together fact patterns across large bodies of content in a kind of like a human would be able to see an entire book at the same time. Or if you ever read, I guess I've never talked about this before, but this is kind of how I think about it. Did you ever read A Wrinkle in Time when you were a kid?
I not only read it, for my 4th grade birthday party, took a whole group of kids to go see the play.
I love it.
I was deep in Madeline L'Engle.
I love it. Yeah, so that idea, I think in this book, there's a creature that can perceive three-dimensional beings in their totality, and sort of as a kid, I always wondered what that would be like, and the sort of seeing internal structures in a body or in an object as though they were surfaces that we perceive kind of in the planar view that we get through our eyes. But this idea that, there's an entity that can perceive the entire volume of a three-dimensional object as though it was surfaces. I kind of I thought of language models kind of in that same way, where they would be able to see every page in a book simultaneously. And where you and I have to read one word at a time, language models would be able to comprehend all of it in its totality. And that doesn't appear to be what we get out of these systems. And it's particularly true, so needle in a haystack retrieval is quite strong, in terms of fact finding and directed information retrieval. But this problem that we're solving is really, you might call it recombinative reasoning.
Yeah. So for people that are not familiar, the needle in a haystack thing is if you want to pump up a Vertex model with 2 million tokens, which they're allowing now, you can probably go find the one fact. But you're going to tell us more about recombinative reasoning. I think the contrast you're making is can you hold it all at the same time and make equal sense of it all? That's a much
and synthesize in particular across many documents. So if you have if you think about RAG systems that have text fragments that the system has been exposed to at inference time, the ability to draw connections between those text fragments as a function of large context windows is less powerful than I would have believed a year and a half ago. It's not, I don't know whether that is just an absence of that kind of training data in the pre-training or instruction tuning corpuses. So definitely it's the case that that kind of data, which is deep synthesis-oriented reasoning, is more expensive to produce. Cognitively, the burden of writing something for a human, writing something that stitches together fact patterns across many documents, it's just people get paid hundreds of thousands of dollars to do that work. And so it's expensive to produce that training data. And in contrast to write a letter to a fireman about your dog, which is 8th grade writing task, and you can pay people to do that quite cheaply. What we have had to do as a result of that fact about these systems is orchestrate. It's much more of a classical software engineering problem. We train machine learning models. We operate our own LLMs. We build a systems of systems type approach that you would see more characteristic of a consumer web company.
Sure.
But it really becomes a lot of systems engineering and wiring together multiple different inference calls and critiquing and assessing and online evaluating the quality of generative inferences rather than some powerful new capability that emerges purely from scale in terms of context windows.
So yeah, there's a bunch of things that are worth digging into there. For people that are thinking about this space, like one conclusion you could draw from what you're saying is just dump it all into one context window and send it to the model is like maybe not the most effective technique you've found. Like you're getting
definitively not the most effective technique. I would say,
and I think everybody gets curious about like, well, cool, sounds interesting. Then what? You mentioned a couple things like having multiple systems that are doing different parts of the work. You mentioned online evals that maybe you could talk to us more about and like want you to share what you're comfortable sharing. You also talked to us a little bit about like just team stuff and the problem being more like a systems engineering problem. Probably want to pull on every one of those threads a little bit more and think about like even people that are curious, how do you staff a team here? We get this question a lot, engineering leaders who are thinking about like, what's the right mix to build a production team? But are you willing to give us a little more sense of like, what are those just different systems doing? If stuff it all into one big RAG context wasn't the answer, what are the pieces after that?
Yeah. So if you think about inference for LLMs as the task of predicting the next token in a passage, one of the things I'll observe is that one of the possible next tokens to predict is the stop token, right? So what you see is as passages get longer, the likelihood of generating a stop token increases. And so it's very difficult. I've never seen a system that'll give you, 10,000 tokens of high quality writing. And the result of that is, if you think about writing a book report versus a synopsis of each chapter in that book, you're going to have about 1,200 tokens to compress a set of information into. And if you're trying to encode information about a book in 1,200 tokens, you're just going to have less descriptive granularity than if you have n chapter synopses of 1,200 tokens each. And so one of the things that we've seen is that decomposing the problem into constituent subtasks and analyzing more focused, specific bodies of text independently of one another, and then recombining intermediate work product is an extremely powerful method. And I will kind of leave it at that level of granularity. I think it's a fair bit of this is net new IP that we have developed for how to structure that reasoning process, but definitely decomposing the problem into different subtasks and then focusing on the most granular unit of analysis that you can. Part of why our systems are able to get such high quality insight out of, you think about the SEC filings, it is just rife with boilerplate. And so to the extent that you can spearfish for the most interesting content and then reason about that, and independently of the boilerplate, I think you get much, much better results out of a system like ours.
Totally. That makes sense. And going back a year and a half ago or something, in like the early days when people were spending a lot of time on RAG systems, the novel thinking back then was like, oh, you can do this kind of just giant summary, or you can do like a produce pattern and try to like summarize the summaries. And sounds like you're saying like those more discrete things have been productive.
Yeah. Invite anybody to put an SEC filing into a Gemini context window. Even I think 128K to do it, and ask it to describe what it finds, and you'll get things like currency fluctuations and like all of these sort of most uninteresting parts of that document will be front and center.
Right. That's kind of like become a hello world task almost for doing stuff with LLMs, like stick a 10K into a model and see if you can derive some magical financial insight. Part of why I got inspired to reach out to you to have this conversation. You put up some content, maybe it was a couple months ago now, maybe it was 6 weeks, I forget, but there was this bearish Goldman Sachs report, I think, about like how AI wasn't really going to pan out into anything, and the hype around generative AI was not real in production, was kind of the conclusion that you basically said, well, here's a great 2-page summary of that 30 something page report that captures all the highlights and helps you understand quickly what's in their dense, hard to read report.
About how this is not useful.
Like that's a great practical example of, I think, the kind of benefit you all are trying to create. What kind of response did you get from that? Like, do you feel like that one actually? Did other people agree? I think you
garnered
you
a lot of
a punchy tweet, but what do people think?
It garnered a lot of attention, which was great. But additionally, I think we've had some people who have seen that document and are surprised that we were able to do that, because again, it's not something that you would get out of putting that report in, upload the PDF to ChatGPT and say, describe this to me. We have a rich, semantically meaningful internal representation of documents that any document in the world is cast into an internal representation that allows us to reason over it in a semantically aware way. And our ability to understand what's salient and extract, the most information dense parts of the document, and then also weave those together into a coherent narrative. I think it's been a great calling card as an artifact of, this is work product from the Brightwave system, and this is what Brightwave is able to do with just one document. Now understand that Brightwave's real value is connecting the dots across hundreds of documents. And that is when you start to have that eye-opening moment where it's like, wow, this system is substantially more powerful, and the whole is far more sophisticated than the sum of its parts.
And I mean, so you're talking about but this, like, from a system standpoint, I think you've hit some of those architecture things around, I think you're kind of getting flavor. There's pieces, different workers in the system, different services stitching together this information. You mentioned another part of the success, which was specifically, you said online evals. But maybe if I would phrase the question in a more open-ended way, the Goldman Sachs report, you made a good summary. How do you know if it's good? How do you figure out when things are bad? I think if we could just have a little chat about evals, it'd be interesting to hear how you approach this space.
So I think that good is, like, you ask a kid, like, were you good today? Like, a material fraction of a person's life is developing an internal model of what good is. What does society want from me? And it's actually a very complex question. And so we as people have to decompose good or moral or true into sort of with respect to which aspect. So I think you can't ask an LLM to say, is this an insightful example? And I would say that LLMs are conspicuously bad at understanding what is surprising or what is insightful or what is not obvious. In part because they are almost by definition finders of the typical. But you can decompose good into problems like entailment. Is this statement factually entailed by the premises on which it is based? That is much closer to a task that a language model can perform. Is this grammatically coherent? How many paragraphs is it? I think you can assess what are some of the subcharacteristics that, if they are all in the same place at the same time, would be correlates of insightful financial analysis, for example. And we do much more than what I've just described, but I think that kind of respecting the limits of the technology in terms of what it's actually capable of accomplishing. And a good comparison is, have you heard of the Valley of Informed Pessimism? So,
sounds interesting, but I can't.
The startup journey, sort of, you've got the sort of peak of uninformed optimism, and that's when you start a project, you're like, this is going to be great, and then you go into the Valley of Informed Pessimism. And it's like, damn, this is a lot more complex than anybody sort of told me. I appreciate it. And then if you push and if what you do works, you get to the next peak, which is the sort of peak of informed optimism as opposed to uninformed optimism. And I think you can't be rebuffed with your first attempt. And it's like, well, this thing, it's not able to judge whether something is insightful. And the real task then is, okay, well, how can we operationalize that in a way that does not ask the system to do something it's not capable of, and instead focuses on problems that it is capable of reliably performing, tasks it is capable of reliably performing.
It sounds like you've got, like, some of those examples. Entailment's probably a practical one. Like, you're running some panel of evals.
Yeah, generate candidate inferences and then assess them and then select, N of K, and choose K inferences that are favored according to our criteria of what relevant, instructive, insightful would be.
For sure. And like the way that you describe the problem, we talk about this a lot too. Like the instinct with a lot of teams when they're getting started in this space is like, well, I want to run an eval to see if it's good. And, we talk about it's like almost a social science problem. There are all these different ways to break down the problem and think about how you interrogate a system like this.
Yeah.
You hit a couple of them. I assume you didn't get there just by having some automation run in your software. How do you, or did you, or do you still discover what are those right high value evals to run?
Yeah.
What's the process look like to actually, like, we're on the same page philosophically, but like, how did you take apart good and start to make it pragmatic?
I think I would say that there's kind of a tick-tock motion with regards to measurement and qualitatively just basking in the gestalt of what you've built. It's a $10 sentence, but it is actually what I mean.
That was a great sentence.
Yeah, it's like another way to say just like look at the data. And this is where some of the background that the team brings to bear on the problem, and we've got an incredibly strong team. I'm 20 feet from me as a guy whose work is published at NeurIPS, is that what you would in traditional machine learning call error analysis. If you have a confusion matrix of true positives, true negatives, false positives, false negatives, looking at where the model is wrong in surprising ways, and then seeing what feature is not captured in our model that would lead it to, what is the human level intelligence that would know that this is in fact a true negative rather than a true positive? And we're not measuring the following characteristic of this record. And you add that feature to the data set, and now you retrain the model, and now it suddenly no longer makes those mistakes. That's where, because we don't have, in contrast to supervised, classical supervised machine learning problems, we don't have ground truth labels generally. Just looking at candidates and being able to view multiple different inferences with respect to a query, and what are all the candidates that the system produced, or if we're looking at pairwise comparisons, like which, what states does it
better
sort of lose the plot. And then I think trying to operationalize that and tie that back to, this, here's an eval that we can run that will capture, is there a causal inference here, for example? And those sorts of things, I think it's just you define the set of things that you measure, assess whether those measurements are reliable. I mean, that's a major problem, is that you can have unreliable instruments.
Yeah.
Improve the system under those measurements, and then sit with it in either a production environment or in a playground environment where you can just look at a lot of examples and then improve your measurements, and then push it to prod, and then improve your measurements, watch it, push. And so I think it's that kind of it's like tightening a ratchet.
Yep.
Where it just gets tighter and tighter and tighter. And it just has less room to do the thing that you don't want it to do.
It's like pure brass tacks. Is that the same person? Is that a different role? You've got this nuance where you're trying to figure out, what does an equities analyst want to know that is valuable in this, document summary or in response to a question? You've got instrumentation of online evaluators in this complex, systems engineering architecture.
Yeah.
Just practically, who does the work? Like, how does this come to be in the company?
I think that we're fortunate in that we have former equity analysts, former investment bankers on the team. So folks who worked at, UBS and Goldman and McKinsey, who are just, effectively able to do the human level intelligence task. Like, if we did not have language models, these people would be able to do the work. That is the gold standard for, is this relevant? And I think particularly in technical domains like law or medicine or finance or scientific research, it's important to have that expertise available, because what an amateur, but like an amateur who's paying attention, might not notice about the terms or clauses in a bond offering. It might not, you and I might not notice the subtleties that a finance professional would. And, that's important.
That is certainly true for a bond offering for me. Yeah, I would not.
The world turns on that kind of stuff. And so I would say that having, for the class of problems we're solving, generally it is not appropriate to solely rely on an engineer's judgment in terms of, is this high quality? So our commercial, our product team and our engineering team work hand in hand to make sure that we are capturing what matters. Because it is a high skill task. Yeah.
And that's basically the answer that we hear over and over again from people that are really running LLM systems in production. I
Yep.
think it's been, and you've had some background here. You talked about some differences with classical machine learning
Sure.
problems. Maybe it's worth going that direction, but the model companies, the people that are doing research and foundation model training, I think it's pretty well known that like they work with companies like Scale to do massive data labeling operations. Flip that over to people that are actually using these APIs and building production
Yeah.
products around them. So often it's like, well, we've got some very expert in-house folks
Yeah.
that are working on very nuanced quality and prompt engineering and eval problems. And so we just keep seeing that pattern. But maybe like the question going down that road is, how do you think about having run traditional ML teams? What is different about building with generative models from a practice standpoint? And maybe start there. We would love to talk some about just team and staffing too, and how you
Yeah.
think about the kind of roles you need to be successful building around LLMs.
It's hard to say objectively and in a way that would be true for other people because I've only ever been on teams that I've been a part of. But I would actually say it's not that different. And I don't know if that's a consensus take or a non-consensus take, but the fact of the matter is that most everybody is learning about the applied uses of this technology at about the same rate, right? It's like even if you had clear understanding of the transformer dating to 2017, boy howdy, November 2 years ago was a sea change for everybody. And now you look at the model safety cards and these things are 100 pages long. And it's like describing the manifold of behaviors that are possible for these systems is really, really difficult. And I would say that it's just time and seat with the tool. Just how many inferences have you seen? I think is probably a good proxy for how expert are you at using these things. I would say that we don't, for example, hire for people with like, I'm an LLM specialist. I think that is like not that interesting. I also think a lot of the fine tuning work that was a year ago fairly challenging is now effectively a commodity. And so
There's also not a lot of you in the world. Like you can't hire.
Sure. Yeah. I mean,
people practically that are trying to scale this stuff can't go.
Yeah. And so I think to the extent that you can lean on teams of people who have backgrounds in, if you think about like the kind of individuals you would have worked with at Twitter, like feed relevance, man, that is a lot like major parts of the problems you deal with in building RAG systems, right? You have to retrieve from multiple different indices, and then you have to blend those together into a federated single, like full ordering of content. And it's like, wow, that's a lot like RAG. And so I think that
search relevance, like everybody's suddenly a search team overnight.
Yeah.
They're doing pinecone and vector.
Yeah. And exactly. And so getting folks on the team who just had a lot of exposure to the ways to build the sort of considerations in building machine learning systems. And then particularly, I think having that experience iteratively improving and refining a model in a supervised learning context, sort of people who naturally feel how conspicuously absent that is when it comes to building language models are going to be the first people to build evals that allow you to get a close proxy for that. You can't perform gradient descent on those evals, but you can just at least kind of brute force it. We have a pretty even mix of machine learning talent and engineering talent on the team. I wouldn't commit to a specific proportion. I think at Brightwave, we fit the job to the person. And in general, we try to hire for ownership mindset more than anything. But it is very difficult from a distributed systems engineering standpoint, and not a distributed systems engineering, just systems engineering standpoint, to stitch together all of the different pieces without strong systems engineering capabilities. Because getting high quality work product out of these systems requires multiple different checks and controls on intermediate work products. I think that is one of the primary reasons that the gap between demo and production worthy is so large, is that getting the demo stood up is fairly straightforward, but then engineering the system that can reliably orchestrate everything is still a fair bit of work.
Yeah. And more of a systems engineering problem. And maybe like, I'm curious about that one too. I think I mentioned it before, like we talked to a lot of engineering leaders who are thinking about, we're growing in this area. We're being pulled even into becoming an AI organization. Who do we go hire? And there is just a reality that there's 2 orders of magnitude more experienced systems engineering, software engineers in the world than there are people that have built recommender systems at consumer scale, right? Like maybe 5 orders of magnitude. What have you found as you kind of have like a mix of folks on the team, someone who's published at NeurIPS and people that are just strong systems engineers? What's the cross-pollination look like? Like, is there anything you've learned about the playbook to kind of help ramp people into this space who haven't been building in this world previously?
So I'll tell a story about my collaborator, Matt Hayes, who I worked with at Databricks. I mean, I worked with for many, many years and across 3 different companies, and he kind of partner in crime for many years.
Yeah.
He's one of the best software engineers I've ever known. He is able to achieve more than other people are in the same amount of time consistently.
Yeah.
And I sent him probably 15, I think, papers and blog posts, the illustrated transformer. And he and I went to work, and 4 or 5 months later, DALL-E existed. And so I think like strong software engineers with good computer science fundamentals who've taken linear algebra can understand what to do if they have the right content available to them. And I think that is something that I try not to be too provincial when it comes to who can understand what cosine similarity, for example, measures. It's like not a difficult concept. Sure. And it's just like explain it to somebody who's paying attention, who wants to learn about this stuff. And I think like many problems become very straightforward. And especially if you've got other people on the team who can help with some of the like methodological, like what should we do next? How could like the system's not working? What should we do? That's much more like experience based. But hey, if we know what we need to do, and I need a system that can allow us to rechunk and re-embed content in a way that keeps full text search index, a vector search index, and a relational database in sync, and allows you to do a hot swap of those indices like that, those are problems that software engineers can solve. And I think as you start to get exposure to the methods, you start to say, well, listen, I'll implement the NumPy operations this time. And it did just kind of, I think these are very learnable skills.
We found the same thing, right? We have a mix of people on our team, people that have worked on search relevance problems before, built ML systems at scale before, and then like just some incredible software engineers, and everybody's cross-pollinating in a great way. And there's a lot of those moments that are, how should we approach this problem? Great. Now let's bring it to life. And yeah, I mean, that's been our experience. Cross-pollination is very useful. I mean, we've got a few minutes left, like maybe to shift gears a little bit. We've had a lot of technical topics. For the people that are operating a level up, who are thinking maybe about just product design, investing in this space, one big question, kind of things you're working on, how do you think about the future as the models evolve? There's a lot of chatter right now about Strawberry and Orion coming from OpenAI and these superior reasoning tasks that they can do, or those models can do, and then what that means for things you might be building today. Just be curious to hear your thoughts on how you approach that as a founder.
Yeah, it's fun to think about that stuff. I think to date, especially in the last 6 months, I found it to be very low signal, especially the chattering class on Twitter. Where are the receipts? Let's see the models, and we can speculate about planning and multi-turn backtracking and like an RL system that's jointly co-optimized with a language model. Sure, I think we plan on these systems getting better. We do not anticipate that we will see, I'm not a maxi. Like, I think these are useful systems that are tools. They are not living gods. And I think that planning capabilities and sort of speculative execution, like certainly inference is going to get an order of magnitude or 2 cheaper. And so that's going to make it easier to spin up threads that go nowhere. And that, I think, makes multi-turn sort of more the kind of like what we think about in terms of agentic reasoning possible, just from a cost to serve standpoint.
Yep.
But broadly, I think like the what if speculation is just not something I wind up spending a lot of time thinking about, because it's just not a lot of information to actually go on. Or at least like not a lot of trustworthy information. The fact of the matter is that access to proprietary data sets remains extremely important, and domain-specific focus remains extremely important. It's like the no free lunch theorem, right? The most general tool is generally useful, but is maybe specifically not the right tool for the job.
Yeah.
And so some of this then gets into product form factor, because chat is great for question answering. But if you want to pivot through a knowledge graph, if you want to deepen and refine a hypothesis, if you want to understand many documents simultaneously, the chat-oriented interfaces really start to have just some basic user experience limitations. And I think that the consumer use case, even the enterprise use case for this stuff around like chat and question answering, let's assume that gets a lot better. But the orientation towards a specific workflow, because it is a fact that research scientists and attorneys and finance professionals all
Totally
have different kinds of things that they do in the course of their work. And I think tools that are built in close coupling with those workflows will win in those specific verticals. So it's just,
I've had the same view, right? It's like there's some folks that have looked at this problem and thought, as these models get better, it's kind of the end of software. There's just going to be one Uber model that does all the things for you. Maybe it is under the hood. Maybe we discover there's some just incredible outlier state-of-the-art utility. But I do think that this problem around really solving customer problems in a increasingly niche and nuanced way that just makes somebody's life, somebody's job better. I'm bullish that there's going to be a proliferation in great software companies versus the collapsing all into one thing. So probably see the world similarly there. Maybe like just last thought, closing thought, if you were, talking to a leader at a bigger company looking at this space, or a founder looking at getting started who's maybe a year behind you, what's the one bit of advice of just lessons learned in the trenches that you give as a parting thought?
It's kind of maybe it's obvious, but just use the tool. Just use the tool as much as humanly possible. Get as many inference reps in as many different contexts, and just start to develop a rich internal model of the capability set, and that will inform the systems you design and the products you build.
Yeah, well said. Awesome. Well, Mike, thank you for spending the time. We really appreciate it. And for everybody who's watching, go check out Brightwave, see what they're up to.
Yeah, brightwave.io. We're hiring across all roles.
Awesome. Thanks again, Mike. See ya.
All right, that's all we have for today's episode of Deployed, the AI product podcast. I'm Ian Cairns, the CEO and co-founder of FreePlay. I hope you enjoyed listening. And if you did, we'd love for you to tell others about it. Give us a quick like, share, or subscribe wherever you're listening. It makes a big difference. If something stood out to you about the episode, or if you've got feedback or ideas for a future episode, or you simply want to learn more about FreePlay, shoot me a quick note. I'm Ian at freeplay.ai. You can also find me on Twitter. I'm at Cairns. It's CAIRNS. Thanks for listening.